Right, in this video, we'll cover numbers in JavaScript, how they're represented, the different ways to write them, some useful number methods, and how to handle really large integers with BigInt. So, unlike languages like Java or C++, JavaScript has only one number type. All numbers are 64-bit floating point. Following the IEEE 754 standard, there's no distinction between integers and decimals. Let me show you an example. So here you see a floating point number, and if I ask for what is the type of this variable, it's just going to tell me that it is a number. It's not going to say it's a float or a double. And you can see that I updated the value to be an integer, and if I ask for the type of the variable again, it's going to repeat that it is just a number. So JavaScript just has a number type, and you can think of it as this is equivalent to a double in Java, for example. So when it comes to the precision of these floating point values, it's going to have the same shortcomings and issues that floating point numbers have in other programming languages. For example, you're going to have round-off errors. Here's an example of it. If you do something like 0.1 plus 0.2, the answer is going to be 0.3, but if you actually print that value out, you're going to see that there is a bit of a, let's call it junk at the end of that value. It's not that the calculation is incorrect or there's a bug in JavaScript that is actually expected. It is a numerical error that arises as a result of how floating point number works in almost every programming language. So you just need to be aware of it. The other thing that this example shows is how when you work with integers, literals that look like integers, you're basically operating with floating point numbers. So when I do 1 divided by 2, I'm going to get 0.5 or half. Now, if you were to write this code in a language like Java, this is going to end up being an integer division. And so the result of this is going to end up being 0 because you're dividing integer 1 by integer 2. Okay, so let's talk about number literals a little bit more. So you have, as you've seen, you can use decimal values. You also can use exponentials. You can use hexadecimal values, binary values, octal values, and these are various examples of it. So for instance, 420e minus 1 means 420 to the power of, times 10 to the power of minus 1, which effectively means like divide this by 10. This is a scientific representation. And so the result of it is going to be 42. All of these examples are basically different ways of writing 42. So like this is the binary representation of 42. The 0b is a prefix that says this is a binary representation, and then what follows at 101010, this part is actually the binary equivalent of 42. So if you run this, all of them are going to print out 42 for you. Okay, now there are some special values when it comes to numbers. Let's take a look at these special values as well. So you have, for example, infinity and negative infinity or minus infinity. You have not a number, and these are the values that you get when you do special operations. For example, if you divide something by 0, you're going to end up getting infinity. If you divide a negative value by 0, you're going to get negative infinity. If you try to do something that is like an impossible math, for example, you try to get the square root of negative 1, then JavaScript is going to give you NaN, which stands for not a number. You also get NaN when you try to perform operations that supposed to result in a number, but for whatever reason that process is not successful. For instance, there is a built-in operation in JavaScript. It's available in global scope. It's called parseInt, and what it does for you is that it tries to parse a string into an integer. So if you like change this to something like 2, but this is a string 2, and you try to parse it, it will basically convert this value to numerical representation of 2. This is very helpful when you build web application. If somebody goes and enters something on a form on a website, most often what you receive as a result is going to be a string. Or if you fetch something from a server or read some query parameters of a URL, these naturally going to be entered as strings because you're just reading text. But sometimes the thing might meant to be a value, and so you use parseIn to convert that string into a value. But if you give it something that it's not able to parse it, then it's going to give you not a number, or NaN. All right, now earlier we've seen that strings had helper methods that you could use to, for example, get the length of a string or convert it to uppercase, lowercase. There are some utility methods for numbers as well. If you declare a variable which is a number, then on that variable you can invoke some operations. So let's take a look at an example of it. So if I declare a variable like num with a value 42, then I can, for example, call to a string on it, and it would convert it to a string, but the parameter that I'm giving here, that I'm passing to the to a string operation, is the base of that conversion. So for instance, if you want to convert 42 to a binary representation, then you would do to a string and you give it the base 2. Or if you want to use a hexadecimal, then you give it the base 16. And here's another one. I have pi, and then if I want to set the precision value on it, then I can use the to precision operation. So you can run these operations and see that they produce the expected output. All right, so you've already seen an example of parseIn, but there's also parsefloat. And when it comes to parseIn, you can also use different bases for it. So let's take a look at an example of this. This might be helpful occasionally. So the regular thing is, just give it a string that is supposed to be a number and ask it to convert that to numbers for you. Then you can also optionally provide a base for that conversion. And so here, for example, I'm giving it 2a, which is the hexadecimal representation of 42. And then if I say this thing that I'm giving you is a hexadecimal value, so it means its basis is 16, then it will convert it to 42 for me. And you can parse float as well. And notice that there is this number or object that I'm using to invoke these operations on it. But you can also invoke these operations without the number. That way also works as well. So these operations technically are part of the number object, but they also exist in the global scope as a convenience. So you can just directly invoke them. All right, now speaking of this number object that has a bunch of utility operation, it gives you some other interesting operations that you might find useful. So these are examples of it, some examples. So for example, if you want to check if something is not a number, this is very helpful for guarding against errors. If you want to do a calculation and then make sure that you didn't end up with NaN, you can basically use like number.isNaN. And so there are a few other things like isFinite, isInteger, and you can see the result of these operations. All right, now the final thing that I want to talk about and put it sort of on your radar is that the regular JavaScript numbers can only safely represent integers up to 2 to the power of 53. Well, 2 to the power of 53 and then -1. So that's the range of the values that you can represent. If you want to go beyond these, which you wouldn't encounter in perhaps like day-to-day application, but there may be some special application that you need to work with big integers. And if that is the case for you, then JavaScript has a special BigInt type built into it. And so you can use that to represent very large integers. And the trick to do it is to add a suffix at the end of the number that you want to represent. So look here that this is a very large integer, and then at the end of it I put n, and when you put that n at the end of it, then this thing is going to end up being a big integer. And so you can, if you like do the type of, then it will print out that this is a big integer for you. And the nice thing about big integer is that you can perform like arithmetic operations on them. So if like I want to double this large integer, I can say this variable, which I called it big, times 2, but notice that I also need to include the n. So the like both of the operands of this operation are supposed to be BigInt. You can mix BigInt with regular numbers. So this works, but if I go and comment out this statement, like I just want to add 1 to this big number, it's going to complain to me and say that you can mix BigInt and other types. All right, so we covered JavaScript numbers. Essentially, all the numbers in JavaScript are 64-bit floating points. JavaScript has different literal formats. It has some special values for things like infinity, not a number. There are a bunch of useful number methods for parsing and formatting, and also there is BigInt for large integers.